Alright, so the video you need to see for tomorrow's math lesson is this one. Our objective, what we're going to be trying to do, is find all the factors of a number and determine if it is prime or composite. By it, I'm referring to the number that we are given. Okay? Key vocabulary. If you have to determine if it's prime or composite, you need to know what those words mean. From 3rd grade, prime numbers can only be made by multiplying the number itself and the number 1. So only be made by itself and number 1. Composite is more complex. It is any number that has more than 2 factors. I've made a little T-chart here. This side is prime numbers and this side is composite numbers. And if you look, number 11 is special because it is just prime, meaning it only has 2 factors, 1 and itself. If you were to have little round counters like you used to use in 1st grade and you lined them up in different ways, the only way you could do 11 counters is if you did them one at a time in one single row. If I tried to make 2 rows, 1 row would be longer than the other. Or if I tried to make 3 rows, again, one of the rows would be longer than the other. So only 1 times 11 makes 11. In contrast, composite 9 is made of 1 times 9 or 3 times 3. And remember, we only list the double fact with one of the digits. Meaning 1 times 9, you can lay out the counters one at a time in a long row of 9. So 1 times 9. Or you could have done 3 across and 3 down for 3 times 3. So that one has 2 different ways to make the number 9, and there are more than 2 factors. Okay? All right, as we've discussed, there are 2 ways to decide if a number is prime or composite. And one of those ways is to model it with a picture. And the other way is to consider your divisibility rules. If a number is divisible by more than one of those divisibility rules, then you know it's not prime. It'll have more than just that one factor. So let's consider the number 25. Okay. Here's our first example. If we model 25, and I'm not going to break out my little red and yellow counters, I'll just draw. If we model 25, we think, what are all the ways I can show 25 with little circles or whatever you have? I know that if I can lay out 25 of these little guys all in a long chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Boy. So we've got a 1 by 25, so it is 1 wide and 25 long. We could also do, can it be divisible by 2 if it ends with a 5? No. Can it be divisible by 3? 2 plus 5 is 7. Is 7 divisible by 3? Nope. 4 times nothing makes 25. Our next one is 5, and it can be divisible by 5 because it ends with a 5. So 5 times, let's see if I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many times will I have to do this before I get to 25? Right now I've got 5, 10, 15, 20, 25. So 5 this way and 5 this way, that's 5 times 5. So when I look at this, I say, well, it has more than just 2 factors. It has 4 factors. So this number is composite. And I used both modeling and I thought about my divisibility rules. Let's try another one. Let's say we use the number 17. Okay, so we start off with 17 long, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is 1 by 17, 1 this way by 17 this way. Is it divisible by 2? No, it does not end with an even number. Is it divisible by 3? 1 plus 7 makes 8. 8 is not divisible by 3. Is it divisible by 4? Considering the divisibility rules, no. 4 times nothing makes 17. 5 doesn't end with a 5 or a 0. 6, it wasn't divisible by 2 or 3, so no 6. I don't know any of the other ones that go in there. This one looks like it is going to be prime. There is no other way to lay these circles out into more than one row without one of the rows coming out longer. So that makes this a prime number. Okay, 17 is prime. Okay, and 25 is composite. Okay, let's try. I'm going to go ahead and post your questions for the night. Hopefully you can get to them. I know this is going up later than I had planned. If not, we'll give you time in the morning.